Thank you very much. So I will talk about a method to improve metrics for speech translation especially, but it's not limited to speech translation. It could also be applied to machine translation. We apply this method in the context of Swiss German speech to text because Swiss German has no standardized writing. The speech to text for Swiss German is usually a speech translation. So we usually have Swiss German audio and we transcribe it to standard German text. All the datasets available are usually single reference evaluation datasets, so we only have one ground truth sentence in standard German. So common metrics usually reported in the literature are for speech to text system usually word error rate and sometimes character error rate. When it comes to speech translation, usually the BLEU score is applied, which would enable multiple references, but these are usually not available in the data sets. So we use BLEU with just a single reference. So what is the perfect transcription for a speech-to-text system? Usually it depends on the use case we apply the model to. But in general, we can say that if the sentence is grammatically correct, so it's a sound sentence in standard German, and it fully captures the semantic meaning of the ground truth sentence, we can say it's perfect transcription. But these applied metrics, like the word error rate or the BLEU score with a single reference, they have some limitations. And in the case of Swiss German, these sentences tend to be paraphrased compared to the standard German ground truth sentence, because usually the sentence structure in Swiss German is a little bit different. So here we see some perfect transcriptions for sentences. So we have a reference sentence, for example, gesucht wurde auch im nahen Ausland, and the hypothesis from a model, the model output of a speech-to-text system is auch im nahen Ausland wurde gesucht. And the BLEU score is pretty low, the word error rate is pretty high, and the character error rate is even higher. But essentially the sentence is grammatically correct, and the semantic meaning of the ground truth is captured. So there wouldn't be a reason why this shouldn't be accepted as a perfect transcription in this case. And there's also another example here, a little bit longer sentence. Der Spatenstich fand im Oktober letzten Jahres statt. Der Spatenstich fand letztes Jahr im Oktober statt. So this could be the case here that because it's spoken in Swiss German, one could translate it as der Spatenstich hat letztes Jahr im Oktober stattgefunden, and the model does keep this basic structure of the sentence. So there are two things which are special in this case. So we have different sentence structure, and we have also synonyms. In this case, Überlegungen becomes Gedanken, and also in this case, these metrics fail to capture that these sentences could be a valid transcription. So there is a lot of literature to overcome this. For example, one method is to generate new paraphrased versions of the ground truth sentence automatically with a model which can paraphrase sentences. And this is to increase the valid space of semantically correct sentences. But there is only limited success with these methods. But lately, the paraphrase generation models, usually based on machine translation models, in this case we usually use German to German translation models, which are able to paraphrase sentences. And this improved a lot recently. So it's good to check it out again. Our approach is a little bit different and is denoted as parabove, because we not only paraphrase the reference sentences and augment them with new paraphrased versions, but we also paraphrase the hypothesis, so the model output. We use the PRISM model for this as a paraphrasing model, a model which is capable of paraphrasing, which is basically a model which never learned to paraphrase explicitly, but in this case we use the model to translate German to German and penalize n-gram overlaps. And this is a method to then generate new sentences which are not exactly the same, which basically this model would just predict the same as output. But if we penalize the overlaps of multiple words, we get a new paraphrased version of the sentence. So this could look like this. We have the original reference, the ground truth value. We have the hypothesis, the model output, and then we generate paraphrased versions of these, for example, like 5 or 10. And then we not only calculate the metric value, like for example in the case of BLEU, where we have multiple references, we can have to calculate this n times n. And in our case, as an aggregation method at the end, because we want one numeric value, we use the maximum of all these values. There are also other possibilities, like for example the mean, but in this case the maximum seemed to work the best. So there a little bit of an intuition why this should be better, like just generate new references. So in our case, this was a method we thought about when we tried to increase the probability that we actually match something, because the chances that we exactly match the hypothesis are very, very low when we only generate like 5 new paraphrased versions of the reference. But if we do this on both sides, the reference and the hypothesis, the chances that we generate the same sentence as a match is much, much higher. Because also these paraphrasing models, they have somewhat preferred structure, a sentence structure, and in this case it increases the chances to have a match. But again, this could also be a problem, because we could also match things which are semantically not the same. But the paraphrase model generates sentences which would match, but they shouldn't. We will see this later. So here are some examples. So again, the same example. We have gesucht wurde auch im nahen Ausland, and we see the new generated paraphrased versions of this sentence, and also the same for the hypothesis. And in this case, the third paraphrase of the reference and the second paraphrase of the hypothesis match perfectly. So in this case, we are happy because we want these sentences to match. Here we have another thing which could happen. Here the fourth reference paraphrase matches the original hypothesis of the model. So in this case, just the augmentation of the reference sentences would already be enough to have a match. And here we only have a match of a sub-sentence, only part of the sentence matches exactly. Yeah, this could also happen. And in this work, we created a new dataset with 1,000 samples, which are human annotated, with a similarity rating. So a human decided if he is happy with the transcription of the model. And these samples come from speech-to-text systems. And we also annotated grammar rating, just binary value, how good is the grammar, is it fine, and also the punctuation. But for this work, we only really use the semantic similarity rating. And this is our definition of the rating system. In this case, a perfect rating of 3 would be that the reference message in the original sentence is fully captured without any ambiguity. This could also happen if there are little grammar mistakes. So the semantic meaning of the sentence could still be captured. And a rating of 2 would mean that we have the lack of or the abundance of an insignificant detail. So in our case, we count, for example, the misspelling of named entities as insignificant detail. But it depends on the use case, of course. And the rating of 1 would mean that a main part of the semantic meaning of the original sentence is not captured. But something is still there, and the 0 is that it's just not the same semantic meaning. So here we see the results. We looked at something like the tau-like correlation and the Pearson's R correlation. In this case, the higher the better. We see the original word error rate. Here, the pararef version. This is the version we denote as pararef, which means we only augment the references. This would be the method which is already in the literature. And we see that we can, with this method, increase the word error rate. We also see it here. And we have a maximum of the correlation to human judgment at about 11 paraphrases. And in the case of our method, where we augment both sides, we have a much larger increase. When we compare with the word error rate here, we see how it increases already with 1 paraphrase. And the maximum, interestingly, for all the metrics, for the word error rate, character error rate, and the BLEU score, are at 6. And then it goes down again, because we have something like overestimation. Sometimes we also think that with this method, that sentence fully captures the semantic meaning, but actually it's overestimated. So we see we can significantly improve these metrics with this very, very easy method. And here we see the distributions compared to the rating. So our rating compared to the metrics, how these ratings are distributed. When we have the original BLEU score with the single reference, we see that our ratings of 2 and 3, we cannot really distinguish these two. These distributions are very similar. This one is a little bit higher, but actually the mean is lower than the mean of the ratings with 2. And when we apply our method now, we can see that we can distinguish clearly these 3 ratings. But we also see that everything went up. So we have something like an overestimation here. So every score, every BLEU score goes up, and it can only go into one direction because we use the maximum as an aggregation function. So the next steps would be that that we would find methods to overcome this overestimation. Also, it would be interesting to actually apply this new approach to other tasks, like for example machine translation. And also another extensive comparison would be appropriate for model-based metrics, which are actually like something like a black box, which directly outputs a metric or a semantic similarity rating. Yes, that's about it.
Claudio, any questions? Yes.
Thank you for the speech. When you paraphrase the reference, do you obtain exactly the same meaning? Or the meaning is changing from time to time?
So if it would be a perfect paraphrasing model, yes, we would still have the same semantic meaning. But these models are not perfect, of course. So if we have the rule that we define a paraphrase as something which keeps the semantic meaning, then yes. But these models, of course, do not always keep the semantic meaning. Yeah.
Once again.
The second question is, it seems, according to your experiment, that the order of the null phrases in German is not so important. You can mix you can form a phrase in any order and you have the same meaning.
Yeah,
but it's still a language.
Yeah, so if you would have a metric which does not look at the order of the words, the problem would be that models would be measured as good, which they are not, because nobody could read the sentences. So you could not just move words around and it would be still a sentence. Yeah.
Similar to him, how do you then actually re-paraphrase? How is it? Do you do some part of speech tagging where you know subject, predicate, object? Or how do you slice your data and then reslice it? I mean, that's the matching on it.
Yes, so in our case, we did this not by ourselves, so we just used a paraphrasing model. Yeah. So and also this model is basically a machine translation model, which is able to paraphrase if we do it smart. Yeah. So, but
I have to check the paraphrasing tool how it is then really, because it's then the whole basis of what you're doing here. Because I mean, if then you're telling me a semantic of the semantic, you can keep checking it, but actually you don't know the true meaning of it. Where's not my true meaning? Because I guess it's blind. It's not. There would be neurosymbolic, which is adding the semantics and really knowing this is true or this is now wrong for, let's say, human. Because this is really the holy grail of AI and NLP, actually. Okay. Thanks.
thank you.
The last question.
Did you see any significant computation increase because of the added distance that you have to compute in your solution?
Yes, so this is an expensive method because we have to generate these paraphrases, and also we have to do these metrics. We calculate these metrics much more. So yes, there's an increase, and also for a very big data set, it would be relevant because it's expensive.
Okay.
Yeah. Can you say something about synonyms and the impact of synonyms on your metric?
Yeah. So actually, we saw that the synonym part in this data we observed is not really the big problem. So that this is just a minor part of the problem, which we did not really.
In the speech to text you were looking at?
Yes.
Oh, okay.
Yeah, this is focused on speech to text system for Swiss German, but it could be expanded for other methods.
Okay. Thanks, Claudio, once again.
Thank you.
Now you have 5 minutes if you want to change the room. We start at 1:45.